2.
Oh, yeah.
Oh, yeah, they quiz. No, it's a matching part, so we're supposed to match it, but
Okay, yeah, I'm confused now. 2 or B?
2.
Okay, thanks.
Do you know the center of the ellipse in number 2?
Yes.
What is it?
0, 0, 0.
0, 0. Why?
X squared.
There's nothing being subtracted from the x, and there's nothing being subtracted from the y. Sounds good. Center is 0, 0. Is it a vertical ellipse or a horizontal ellipse?
Oh, wait, no, wait, I was looking at B. I was
You say, I've heard some people say that this is vertical. Why? Y is the bigger denominator. Simple as that. Okay. Y is the bigger denominator, so it's vertical. Okay? Center is 0, 0. It goes vertical. Now, the last couple of things we put up here with the A, the B, and the C, this stuff makes ellipses by far the easiest ones to graph. Watch how this works. Okay? Let's take a look at, let's just use this graph for a second. You see that it's going to 10, so each tick mark is 2? Okay. Here's how we graph it. Okay? Watch how easy this is. That 36, remember that all the denominators are a squareds and b squareds. So the 36 really means 6. So we're going to go 6 units in the y direction from the center. So 6 units up, 2, 4, 6. 6 units down, 2, 4, 6. Huh. We might be onto something here.
Okay, now do.
And then, what does that mean? 4. So we're going to go 4 units in the x direction. The x direction is
Horizontal.
horizontal. So 4 units right, 2, 4. Oh. I think we know which one it is. When you get those points to graph it, okay, just don't make straight lines. Please don't do that. And say, oh, there's my ellipse. With me here? It does not have to be perfect. God knows you've seen me draw. Okay? But try to be at least semi-elliptical. See, I wasn't even close to drawing what they drew, but you can tell that mine is an ellipse and not like straight lines or a diamond or anything like that. But ellipses or circles are ellipses. The only difference between a circle and an ellipse is in a circle, the denominators would be the same. And think about that logically. Does that make sense? If this were 36 and this were 36, then what would that mean? We'd be going 6 units up and down, and we'd be going 6 units left and right, which means it's a circle. Okay? So, anyway, there we go. B is our answer.
Yes.
Questions there? Good. Moving on. Oops, went too far. So how would you feel right now about graphing number 6? Tell me about it. It's horizontal. I would agree. Centers at 0, 0. I agree. A is 7, so 7 units horizontally. B is 3, 3 units vertically. Connect the dots, we're done.
Yes.
Wow. Wasn't bad at all. What about number 10? Number 10 looks a lot harder, doesn't it? Except for one thing. It's not. And here's why.
You divide by 36.
Tell me what's true about these equations here.
There.
They
you
equal
showed it.
1.
Okay, I was like,
The right side of every ellipse equation will be 1. That's not 1. Can we make it 1?
Yeah.
How?
Divide by 36.
Divide by 36. What happens if we divide by 36?
You have to do it on the other side.
Oh. X squared over 4 plus y squared over 9 equals? Ooh, that just got a lot easier, didn't it?
And then we used to.
And then we do, if they ask us to graph it, then we just do the same thing that we were doing before. Centers at 0, 0. 2 units in the x direction, 3 units in the y direction, connect the dots, all done. Questions there? Okay. Let me be more of a pain. Well, you're gonna have to do these problems, so might as well get prepared for them. Tell me about number 4. You like number 4?
No.
Why not?
It already equals
It's
1.
already equal to 1.
It's already equal to 1, so we can't be dividing to clean this up. And we don't have denominators. Now think about that. Hang on. I want you to think about this for a second. You just told me that the thing that you don't like about this problem is that we don't have fractions.
Oh.
Played
I
it.
think you've been waiting to say that for the entire semester.
See, fractions aren't always bad. All right, so what do?
Big fraction.
We make fractions. This one I think is easy. What can we do? Just put it over 1, which therefore means how many units would we go in the y direction? 1. With me? Okay, but this one's more of a pain because it still needs to be x squared. Well, would 4x squared be the same thing as x squared over 4? No, not the same, but you're onto something. Hang on, let me think this through for a second. We're multiplying by 4, right? Multiplying by 4 is the same thing as dividing by 1/4. Multiplying by 4 is the same thing as dividing by 1/4. With me? And so now, are we in the form we want to be in? Yeah, I'd prefer to not have 1/4 in the denominator, but there's nothing I can do about that. Is this a horizontal or a vertical? Why vertical? Y is the bigger denominator. Simple as that. What is A? 1. What is B? 1/2 is correct. Remember, to get the square root of a fraction, what do we do?
Take the square root of those.
Square root of the top, square root of the bottom. So the square root of 1/4 is 1/2. So we would go 1 unit in the y direction, 1/2 a unit in the x direction. Okay. Remember, and that whole multiplying by a number is the same thing as dividing by the reciprocal thing. You can win some contests like that. I was going to say make some money, but I can never promote gambling or anything like that. But you can say to somebody, I challenge you. What's 6 divided by 1/2?
3.
Think about that.
12.
12. Oh, yeah.
Right? If you said to somebody, I'll bet you don't know what 6 divided by 1/2 is. And they'd go, it's 3. It was not meant in the actual promotion of gambling. Okay.
Oh, as a teacher or as like yourself?
Well, as a teacher, there's no way I could promote gambling as a teacher. That would be unethical, wouldn't it? All right.
It's depressing.
Let me ask you this. How would you feel about graphing question number 30?
Pretty good.
We don't do this.
Instantly, people went, oh, and then they went, wait a minute.
It's
Pretty easy.
Tell me about it.
The center is 1, 2.
Careful about the center.
Negative 1, negative 2.
-1, -2.
-1, -2. Yes. Okay. -1, -2 is the center. It is horizontal. From the center, we would move 6 units in the x direction and
3 units in
3
the
units
y
in the y direction. Connect the dots and we're done. So that's not that bad. What about question number 32?
Okay. Divide by
It's not bad because
36.
we divide by 36 and then it will work out nice and clean for you.
Yeah.
Cool. The last homework problem you have tonight is 31, which means that all this stuff we'll talk about tomorrow. And it won't be crazy. It won't be exactly what you want to do, but it won't be crazy. Okay? Mark my words, trust me on that. Uh-huh. Ones at the bottom here, like 28. We can graph that? We can match that, okay? Cool. So then all we have left to do, to talk about, are ones like question number 18. Oh God.
That's not going to be that bad.
We have to find the equation. All right? So in order to find the equation of an ellipse, what do we need? We need the center. Okay? Right now, we have foci and we have vertices. I have not told you yet, and I'm delinquent in my duties in that regard. The endpoints of the major axis are the vertices. The vertices are the endpoints of the major axis. If we know the endpoints of the major axis, is it possible to get the center? How?
Do the distance formula and the
Distance formula?
Not distance formula, but midpoint formula, right? Because isn't the center the midpoint of the major axis? Now, here's the reality. Okay, we can talk about midpoint formula all we want. I am not in a million years right now going to wheel out the midpoint formula. I'm going to look at the vertices or the foci, and it works exactly the same way for both of them. And I'm going to say, what's between there and there? Well, the y, in this case, the y's are the same, so I already know the y coordinate. Y coordinate 0. And then what's midway between -3 and +3?
0.
And there's your center. If it's not that clean and easy, just add them up and divide by 2. Take the average. Uh-oh. Is that stress?
No, my hair's really tight.
Oh.
I still have a question.
Okay. Oh, the question that I didn't let you ask like 20 minutes ago. I'm so sorry.
Is the minor axis always? Oh, never mind. That's fine. Yeah.
I like questions, so if you're not 100% sure, you got it? Okay. Center is 0, 0. If, no, not right now is the answer to your question.
No, that's probably not the answer.
I thought the, okay, go ahead.
So if the foci are less not as far apart, would we use them instead?
You can use either one. The midpoint of these will always be the same as the midpoint of these, 100% of the time. So you pick whichever one you want to use. And the same thing would hold true with the minor axis. If they gave us the endpoints of the minor axis, we get the midpoints of that. Although, if they give us, like here in 24, where they give us the vertices and the endpoints of the minor axis, the great thing is I have no work to do. Here's why. What stays the same in the vertices? For which coordinate? The y is 0. What stays the same in the minor axis? And it is 0. So therefore our center is 0 from there and 0 from there. Does that make any sense? So we don't even have to do a midpoint formula type of thing. Anyway, I'm sorry. Center here is 0, 0. Can we start to write the equation in this case? Yes, and here is why. Remember, in a parabola, we had to wait to start to write until we knew whether it was vertical or horizontal. Here, we can just start to write because the beginning every single time is x minus h squared. So, especially since we know the center, we can already write what? X squared over something, which we'll find out in a minute, plus y squared over something, which we'll find out in a minute, equals 1. Why equals 1? Because it always equals 1. Okay, so all we need are A and B. Do we know either A or B right now? Which one? A. How do we know A?
Because we have the vertices.
Since we know the center, and we know the vertices, and we know that A is the distance from the center to the vertex. How far is it from the center to the vertex? 3, which therefore means that A is, well, A is 3, and a squared is 9. Now there's only one thing we don't know.
Where it goes.
Where it goes. Does it go under the x or does it go under the y? The answer is very simple. In the vertices, which coordinate, let me ask this again. In the vertices, which coordinate changed? Then put it under x. Whatever coordinate changes for the vertices, that's where a squared goes. Now I got one more thing for you on this one, and that is in dealing with b squared. Okay? I never remember this formula because it's very close to the Pythagorean theorem, and I'm going to tell you when we do hyperbolas starting on Wednesday, it's not going to be the same formula. It's going to be a squared plus b squared equals c squared. And I don't feel like remembering any more formulas, so I had to come up with something to make this work. Here's what works. It's either a squared plus b squared equals c squared or a squared minus b squared equals c squared. And the way to remember which it is do the opposite of that to the two denominators to get c squared. So if that's a plus, I'm going to subtract the two denominators. If that's a minus, which we'll see in hyperbolas, I'm going to add the two denominators. Does that make any sense? You can remember this formula if you want, totally fine. But for me, it's just easier to remember, do the opposite of that to the two denominators to get c squared.
What is C?
C is the
Okay.
distance from each center to
C is the distance from the center to each focus. Do we know C? What is C? C is 1, right? Because we got the foci here. So center 0, 0, focus at 1, 0, which therefore means that
9.
C is 1, which makes C squared equal to 1. So therefore, 9 minus this equals 1, which therefore makes this 8. And there's our equation.
So,
Okay, that makes more sense.
okay, but we're good. Never mind.
Did you say that makes no sense or that
No, I
makes sense?
said that makes more sense.
More sense. How are we doing? There's a lot of stuff, but once it starts to click, it goes pretty easily. Okay? Like we started looking at this stuff and you went, oh, no problem with
What
that.
about 22?
Good.
Okay, so couldn't we just give that and just graph the focus? And then when that tells what direction we're in?
Okay, but all I'm trying to do is get the equation.
Okay.
So I want to take the info that I'm given and make the equation with it.
Okay.
What's the next? I heard somebody else talking. What's up?
So what if you don't have any of the foci? How can you figure out what C is?
We can't. Unless we have A and B. But we got to have two of them to be able to get the third. So we'll either have A and B, A and C, B and C, and somehow with them we'll be able to get the third. Or we could end up getting the eccentricity, which you're not gonna see that tonight at all. Okay? 22 you said? Let's look at 22 real fast. See if this, boy, that looks a lot harder, doesn't it?
No.
No. You jumped ahead. It's not that bad.
Okay, did they?
What did they give us? They gave us the center, so that's helpful. So if they gave us the center, I can start writing already, right? X squared over something plus y squared over something equals 1, right? Do you know what A is? A is 5. Why is A 5? Because the length of the major axis is 10. And the major axis is 2A, so A is 5, which makes A squared 25. Now, where does it go? What is that telling us?
It's horizontal.
That the ellipse is horizontal, which means that A goes under X, so 25. Okay?
Oh.
B is 1.
B is 1. Why?
It's the length of the minor axis is 2.
Minor axis length of 2, which makes B 1, which makes B squared 1. So therefore,
One goes under Y.
1 goes under Y.
Or nothing.
Now, we actually probably won't even write it if we do that.
Just that?
Well, we could write y squared over 1, but, and that's it. We're done. Ooh, 22 was easier than I thought. Because they basically gave us A and gave us B.
Okay.
How are we doing? Okay. Tomorrow will be a follow-up of today, but we're not really adding any new material tomorrow. We're just going to take what we learned, we'll expand it some, but it's not going to be, remember what I said the other day?